temperature, humidity, differential pressure, and particle count in a specific area or zone in real time. In maintaining the environment of GMP clean zones, BMS and EMS are crucial systems. Let's explore how they are structured and what functions they perform. With the advancement of modern industry, technological sophistication has been achieved across all fields, including the bioindustry. This has led to more automated production processes and management systems, allowing for safer and more precise operations. As a result, the process has shifted from manual control to an automated system that manages the entire process, from raw material receipt, production, storage, packaging, to shipping. All information and data generated during the process are now stored, recorded, transmitted, and queried in real time, allowing fewer people to manage and operate more data in a more systematic and reliable way than before. This data is crucial because it proves that the products are produced as per their applicable regulations, comply with the approved specifications, and are made in accordance to the laid down procedures. In biopharma manufacturing facilities, in various buildings, equipment and systems are installed to support multiple operations. Managing and operating the systems as required while promptly addressing any failures demands significant effort and oversight from facility managers. In the past, facility managers had to visit the site to manually operate equipment, visually inspect its operating status, and perform on-site checks. However, with the introduction of a building management system, tasks such as starting and stopping equipment, monitoring parameters like temperature and pressure, and detecting abnormalities can now be performed remotely through a centralized monitoring computer. Additionally, the BMS enables storage and analysis of operational data, allowing trends to be identified over specific periods. This functionality not only helps in diagnosing current issues, but also facilitates the prediction of potential future failures, enabling proactive maintenance measures. Now, let's take a look at the BMS monitoring computer screen installed at our center and explore how it is structured and how it operates. Our center's BMS is linked to various equipment and facilities such as chillers, air handling units, boilers, and water tanks. The EMS is set up to monitor the indoor environment of the cleanroom areas. Of course, more equipment and facilities can be integrated, but based on the identified site, operations risks, and associated budget, it is advisable to prioritize the installation of the most critical equipment first. First, let's take a look at the EMS. The screen is configured to display the indoor temperature, humidity, and differential pressure of the cleanroom. While the real-time data can also be listed in a chart format, it's easier to interpret at a glance when displayed on a floor plan, as shown here. On the screen, real-time temperature, humidity, and inter-room differential pressure are being monitored and stored. The upper and lower limits are set for each parameter, and if any of them exceed the normal range, an alarm and message are triggered. These alarm details are also stored. On the left side, the temperature reading of 21.0 degrees Celsius is shown with an HH indicator, meaning the upper limit has been exceeded and an alarm is currently sounding. When alarms and messages appear, the responsible personnel must verify and take action. In addition, it can be configured to display various information in real time, such as whether important equipment is operating or in its status, the number of fine particles floating in the room, and the door interlock status. The screen you are seeing now shows the number of particulates in the air measured in real time in the clean room. If the standard value is exceeded, it is classified into an alert level or action level, and the phrase H or HH appears, and an alarm is generated so that the administrator can recognize it. The time, content, cause, result, and person responsible for the action are recorded in documents to ensure correct documentation. Now, let's take a look at some of the equipment integrated with the BMS. First, we have the AHU. The AHU is a system that has a significant impact on maintaining the indoor environment, so it is closely related to the EMS. In order to maintain and adjust the indoor temperature, humidity, and differential pressure to optimal conditions, the BMS controls numerous data signals to operate various functions such as exhaust, intake, cooling, heating, dehumidification, and humidification in an integrated manner. The equipment you are currently viewing is the drain pump. Here, we can check the status of each level and the pump operation for the drain pumps installed at this center. The operation of the submersible pump can be confirmed based on the water level, and if there is an issue with the level or pump, an alarm will be triggered, allowing the manager to be notified and take action. If it were not integrated with the BMS, it would be impossible for the manager to detect the issue unless they physically visit the site. If the issue is not identified and addressed promptly, it could lead to more severe problems. For example, if the manager recognizes that the fan motor of an air conditioner is broken through the alarm of the air conditioner pressure sensor or the differential pressure sensor of the corresponding room, he or she can take immediate action. However, if the BMS is not installed, it is difficult to know that there is a problem until the manager inspects the corresponding area or air conditioner. If the unrecognized time continues, the differential pressure, particulate matter, temperature, and humidity environments of the corresponding area cannot be maintained at normal levels, and it is very likely that all pharmaceutical products produced in a deviant environment will have to be disposed of. The equipment you are currently viewing is the lighting control system. It allows remote switching on and off of lights by circuit in the designated area. Additionally, it can be programmed to automatically turn lights on or off at specified times, and even be set to turn on automatically in the event of an emergency, such as a fire or power outage. Through remote lighting control, energy savings and user safety can be enhanced. We have now reviewed the BMS and EMS. These two systems are applicable not only in the bioindustry, but also in various other sectors, and they are increasingly being utilized in factories, buildings, and even homes. The technology behind these systems is becoming more diverse and specialized, particularly in energy saving, ensuring user safety, and resolving issues quickly. BMS has experienced rapid growth as a reliable solution across various fields. In the bioindustry, it is crucial to prove the integrity of the data generated throughout the production and packaging processes, so an appropriate BMS implementation is essential. Through this session, we have explored the fundamental concepts and functions of BMS and EMS. Thank you.